So today we're going to talk about binomial distributions, and we can welcome our extra two special classmates. They will be attending class with us today. And in order to talk about binomial distributions, we have to start by talking about a binomial experiment. So a binomial experiment, so when we talked about probability distributions, we talked about the fact that sometimes we get our probabilities from experiments, seeing how often you get ahead when you toss a coin 100 times. Binomial experiments are similar. Okay, so we're gonna talk about the properties of a binomial experiment. There are four things that make something into a binomial experiment. The first thing is that it has a fixed number of trials. These trials are just events. So it might be a question that's being asked. It might be whether it's going to rain on a certain day. It might be whether a crop is going to grow, or whether a team wins a baseball game. These would be examples of events, and they're all independent. Meaning that the outcome of each event is not dependent upon the outcome of any of the other events. So if a baseball team is playing a game, whether or not they win that game has nothing to do with whether or not they won the game before, or the game before that, or the game before that. So these would be independent events. There's a fixed number of them, and we typically call that fixed number of events, we give it n. That's the letter that we give it. So let's put that in a different color. So the number of trials or events. Okay. The second aspect of a binomial experiment is that there are only two possible outcomes for each event. And here, one is described as a success and one is described as a failure. And be a little bit careful about how you interpret this, because a success doesn't always have to be a good thing. So for example, it might be that if we're looking at whether or not a crop grows, that depending on how we ask the question, a success might be, yes, it did grow. Or if we ask the question in a slightly different way, such as, what's the probability that in September the crop did not grow, then the success might be that the crop didn't grow. Okay, so all we're saying is that there are two outcomes, a yes and a no, a true and a false, a win or lose, a worked or didn't work. These are examples of possible outcomes. For example, another good example would be like tossing a coin. A success might be heads and a failure might be tails. We have two outcomes, okay? The next thing that we have is that the probability of the success is the same for each trial. So again, be careful of this. We're not saying that the probability of a success is equal to the probability of a failure. That's not the case, okay? What we are saying is that in each trial, the probability of the success is the same, okay? So think about it this way. The probability that a baseball team wins a game is 0.8, okay? 80% probability. If that's the case, then every time they play a game, it's the same probability. Probability of its success is always 0.8, and the probability of a failure would always be 0.2, okay? And the last thing is that the random variable, which is x, represents the number of successes. And I'm going to put the x in blue because, again, it's a variable that we're talking about. And just so that we have all of our variables in one place, let's just write them down, okay? So we already know that n is the number of trials. We also know that x is the number of successes. And the probability of a success we use p, okay? And as a side note, and we'll put this in green, okay? As a side note, this means that if we want to know the number of failures, we could take the total number of events and subtract the number of successes that we have. So n minus p, sorry, I didn't mean p. I meant x. N minus x, because x is the number of successes, right? So n minus x is the number of failures. Okay, if I have 20 events and 10 of them are successes, then 10 of them must be failures. If I have 20 events and 3 of them are successes, then 17 of them must be failures. Okay, and the probability of a failure, well, if the probability of a success is p, and there are only 2 outcomes, a success and a failure, then we know that the probability of a failure has to be 1 minus p, right? Because either we have a success or we have a failure. So whatever is left over is going to be the probability of a failure. And just as a reminder, this notation is the probability of a success. Okay, this notation is the probability of a failure. So let's just take a couple of examples of binomial experiments. Okay. Let's take the example of a true-false quiz. So here's the example. Let's say that the quiz had 5 questions. And let's just do an example of a quiz for fun. Okay, so for fun, let's do it based on me. Let's say that I give you 5 statements. So I went to Bronx Science would be one statement. Second statement would be I have 4 sisters. Next one would be I once dyed my hair pink. Next one would be I was on my high school basketball team. And the last one is I met President Biden. Okay, so this is a binomial experiment. How do we know? There are a fixed number of trials. So there are 5 trials here. Okay, they're independent because whether or not I get the question, the first statement right, whether or not you get the first statement right, true or false, that's independent of whether or not the second statement is true or false. Okay, so these are independent events. You might say true to my going to Bronx Science and false to my having 4 sisters. But if you said true to my going to Bronx Science, it doesn't tell us what you're going to say for the next statement. Okay, so there are only 2 possible outcomes, true or false. The probability of success is the same for each trial. So the probability of getting the first statement correct is the same as the probability of getting the same statement correct. Okay, in this case, it's 1/2. Either you're going to answer true or you're going to answer false. And the random variable will represent the number of successes. And that's always going to be true. That's not really a check because we're saying it's true. Okay, so let's just make sure that we understand what N, X, and P are. And I will also note that I'll add this in. 1 minus P we call Q. Okay. So let's just put in our variables here. So N is 5. There are 5 events. In this case, an event is a question. Our X, that's the number of successes. That's going to be unknown, okay? X is how many you get right. And P, in this case, is the probability of a success. And since there's only a true or a false, the probability of a success is 1/2. And that means that Q is 1 minus 1/2, which also happens to be 1. half. Okay, so if we got 3 statements right, then x would be 3. If we got 5 statements right, x would be 5. And you can sort of experiment with this. I will tell you, I did go to Bronx Science. I do have 4 sisters. I never dyed my hair pink. I absolutely was not on my high school basketball team. If you have been in any of my classes, then you know I am probably the least athletic person who you will ever meet. I did meet President Biden. He was actually vice president at the time, but I did meet him, and I met his wife. His wife actually also spoke at my doctoral education, my doctoral graduation ceremony. Okay, let's take one more example of a binomial experiment, and then we'll be done. So the other example would be, let's say, for example, that we're talking about whether or not it rains on a given day of the week. Okay, so your experiment is the probability it rains on any given day of the week. And I'm going to tell you that it's 0.55. Okay, so if we wanted to identify each of those variables, well, n is equal to 7 because there are 7 days in the week. In this case, p is 0.55. And Q is 1 minus 0.55, or 0.45. Okay, so notice the probability of rain is the same on any given day, but the probability it rains is not necessarily the probability that it doesn't rain. Okay, and depending on how many days it actually rains, that would be x. So x equals the number of days it actually rained. And in another video, you'll determine, well, how do we calculate the probability that it rained on 3 days, or the probability that it rained on 5 days, or even the probability that it rained on at least 3 days, or at most 5 days. Okay, another example, our last example, might be the probability a baseball team wins a game in a 5-game series is, let's say, they're not so great. So it's 0.23. Okay, and most of these would be followed by a question, well, what's the probability that they win 3 out of the 5 games? Okay, what's the probability that they win at least 2 of the games? So all of this would be followed by a question, but right now we're just talking about what we're talking about with a binomial experiment. So here we can identify each of our variables again. So n Well, we want to know how many events there are, and the event is the game, okay? When we talk about the probability, it's a game. This is talking about the probability of something happening each day. So the event was a day in this case. In this case, the event is a game, and there are 5 of them. So n is equal to 5. Then P is the probability of a success. Since that's what we're given the probability of, P is 0.23. And that means that Q is going to be 1 minus 0.23, or 0.77. And X would be the number of games the team won. Okay, so again, the question would be about what's the probability that the team won a certain number of games? Just like we said, this would be the probability that it rained on a certain number of days. And this one would be the probability that you got a certain number of questions correct. Okay, and that's what a binomial distribution is. So you're going to be talking about how to calculate those binomial distributions in future videos. And that's it for today. Thanks.